All right, go ahead and record. So we're looking at 7.1 measurement. And first type of measurement is the US measurement. Let me get to the notes. All right. So US measurement, the first few that we're going to talk about. Somebody said something in the chat already. Oh, still can't hear anything. Let me type to you guys, classmates. All right, so let's go back to the lecture. So we have a first few conversion factors. 12 inches is equal to 1 foot, 3 feet is equal to 1 yard, 36 inches is equal to 1 yard, and 5,280 feet is equal to 1 mile. So there are way more conversion factors than these. Even if you misplace these, they don't change. So, you can ask Siri, Google, Alexa, anybody and their mom, they're all the same. They'll always be the same. So you want to know how many inches in a foot or how many feet is in a yard and all that stuff like that. All you have to do is look it up. Even if you don't have a book, like I said, they'll still be the same when you go looking at it. So let's look at the first one that we're trying to convert. We want to convert 18 inches to a foot. And let me erase this stuff so we can walk through it. All right. So the first thing we want to do is set up this 18 inches as a fraction. We're going to set it up 18 inches over 1. Now we're going to multiply it times the conversion factor. Now what dictates first which conversion factor is the fact that we're going from inches to feet. So you want to look at the conversion factor that gives us that. And of course, that's right here. Then we will use it one of two ways. Either we'll do 12 inches over 1 foot or 1 foot over 12 inches. So what dictates that is what we're starting with. We're starting with inches. And if that's the case, then I need inches down here. I need inches over inches to be able to cancel out. So that means I'll do 12 inches on bottom and then the 1 foot on top. All right. So once again, if I have inches right here, I need inches down here in order for them to be able to cancel out. And then that leaves me with the feet that I need to be in. Once you've established that, you would just multiply across. 18 times 1 is 18, 12 times 1 is 12 on bottom, and 18 divided by 12 is 1.5 feet. Can't see the screen. Yeah, we're most definitely going to switch to Zoom. Can anybody else see the screen? I see one person saying they can't see the screen.
I can do it.
Okay. Okay, cool. Yeah, when there's one or two people, I really not much I can do for it.
Yes, I can
Okay.
see it too.
Thanks. I appreciate you guys responding to that. All right. So WebAssign may ask for it in decimal, or it may not even care. But if it asks for it in a fraction, what you could have done was, look at the 18 and break it up into 6 times 3. Look at the 12. That's 6 times 2. Cancel out your 6's, and that's 3 over 2. So 1.5 and 3 over 2 is still the same. All right. Questions before we look at the next one.
Excuse me, Professor.
Mm-hmm.
How did you get 1.5 feet again? Can you explain that again? I'm sorry.
18 divided by 12.
Oh, okay.
Yeah, just throw it
Okay.
in the calculator.
All right.
See somebody talking to me. I finished. No, you don't need to show your work. You just show your work for tests. So, you know, when you look to do your first test, then I'll be looking for work then, sending me a copy of your work. But for the homeworks, you're free to just knock them out. All right, next one we have 14 feet, and we want to convert to a yard. So the conversion factor that we'll use is right here. 3 feet is equal to a yard. Once again, you're looking at where you start or what you're starting with. That tells you what you need down here. So I need my feet to be down bottom. So that's 1 yard over 3 feet. And our feet are going to cancel. Let's see, somebody said something. Okay. Once you cancel that, you can multiply across, just like before. 14 times 1 yard is 14, and then 3 times 1 is 3. And 14 divided by 3, 4.6. Oh, it's trying to snow. Okay. All right, question. All right, let's do another one. 3.5 tons. I'm going to convert that to pounds. So, first thing I did was I took the 3.5 tons and converted that to a mixed number. I mean, improper fraction. You know, you take 3 times 2 plus 1 and divide that by 2. Keep that 2 down there. So that's 7 over 2 for our tons. Then we have this conversion factor of 2,000 pounds is equal to 1 ton. So that's what we'll be using. And I'm going to erase this stuff so we can walk through it. All right, so we have 7 over 2, and then tons is our measurement. Remember, if I have tons that I'm starting off with, I need tons down bottom. So it'll be 2,000 pounds over 1 ton. Tons cancel. Multiply across. 14,000 pounds over 2. And then 14,000 pounds divided by 2 is 7,000 pounds. So group chat for this class. Oh, that's y'all. All right. All right. Questions on that? So if you're talking about converting between your measurements, there's a conversion factor that you would use. And the way you'll set it up is by connecting your measurements top and bottom so that they can cancel. You know, just like that. Let me see if anybody's talking to me. Yep, nobody's talking to me. All right.
Excuse me.
Yes, sir.
When we do the work, you want us to show the work and take a picture and send it to you, or just do the
Yes.
work?
Yes, do it that way. Now, I'm only talking about for your test though.
Okay.
So when you're doing your homework, you just do your homework freely. But you do want to get yourself in the habit of showing work because, you know, like I said, I'm looking for the work for your test. But
Okay.
yeah, but for your homework, no, you don't have to.
All right.
Mhm.
Miles, you in here, boy.
Man, we are recording. Sir, we're recording. All right. So let's look at the metric system. And so this is the next type. This is the metric system. This is the system that the whole world uses. The other one was called the U.S. metric system because only the U.S. really uses it. I think the other people, the other world, other part of the world uses it because the U.S. deals with it, so they just deal with it. But the metric system is what everybody uses. And so we have our prefixes of kilo, hecto, deca, and we have our base, and we'll talk more about the base in a second. Deci, centi, or centa, yeah, and milli. And we have our abbreviations, KHDA, and like I said, our bases, GML, DC, and M. And then our values, 1,110, 1, 1/10, 1/100th, and 1/1000. All right. So there are prefixes that go way higher than this. Most of you have experience with giga, gigabytes, mega, megabytes, and all the stuff like that. But then you have ones that are way smaller, like pico and nano. You heard of nanotechnology, stuff like that. So you have prefixes that are way larger than what we're dealing with right now and way smaller. But these are the foundational ones that we're dealing with. So give you a chance to finish writing this chart out. All right. Guys, scroll up. You still copying? Let me know. Let's see, is that for me? Somebody said wait. All right. Give a few more minutes. All right, so we good. All right. So our bases, grams, meters, and liters. Grams measure your weight, meters measure length, and then your liters measure volume. And then just examples of as to how we use our prefixes on the basis. So depending on what you're measuring, you can use either one of those prefixes in front of the base. So you got kilograms, centigrams, kilometers, centimeters, or kiloliters, or centiliters. So what dictates which base you use depends on what you're measuring. And like I said, any of those prefixes can be used in front of either one of the bases. All right. So the next thing we're talking about when it comes to the metric system is remembering the order. So don't forget that all of them have a value and it's in a certain order as far as which one is greater versus which one is smallest. And so that order matters because you're moving in multiples of 10. Trying to write that little meter. So the way you can remember the order It is the fact that King Henry died by drinking chocolate milk. So K for kilo, H for Hector, D for Deca. B is going to be either one of your bases. So G, M, or L, depending on where you're at and what you're measuring. D for Dessa, C for center, and then M for milli. All right. So when you're talking about converting from metric in the metric system, really all you're doing is moving the decimal to the right or to the left accordingly. So that's why the order matters. That's another reason why the order matters. Um, Here we're looking at converting 0.38 meters to millimeters. So going off of King Henry died by drinking chocolate milk, I see kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. All right. So, and don't forget, right here's your base, and that's where just M would be. So be careful that sometimes it's easy to forget that M right there. All right. So we're in meters, and we want to go to millimeters. So we start at meters and go 1, 2, 3, 3 to the right. All right. So we take that 0.38 and go 3 to the right. Use a 0 as a placeholder. And our answer will be 380 millimeters. All right. As long as you have the order correct, then that's how you will convert in the metric measurement system. All right. Let's do another one. All right, we're looking at 12.9 centimeters to hectometers. So you start at centimeters and go 1, 2, 3, 4 to the left. Take your decimal, 4 to the left. And we have 2 zeros as placeholders. So that's 0.00129 hectometers. All right, somebody said something. Oh, that's to group me. All right. What questions before we look at another one? Yeah, not too bad. It's not too bad. You got to be positive. You got to be positive. It's going to stay easy. All right. So the next one, 4.23 decagrams to centigrams. So let's go ahead and let me erase a few things. All right, so we can walk through it as always. So here we're looking at 4.23 decagrams. We're trying to go to centigrams. And start here, go 1, 2, 3 to the right. 1, 2, 3. Add a 0. So, whoa. There you go. All right, we got one more like this just to make sure we're good to go. Any questions? Any questions? All right, good to go. So make sure nobody's telling me to wait. Okay, good. All right, so let's do this last one. This time we're looking at liters, going from milliliters to hectoliters. And I guess I can erase it and walk through it. So this time, like I said, we're going from milliliters to hectoliters. And if we start at milliliters, we're going 5 to the left. So we'll take our decimal and go 1, 2, 3, 4, 5 to the left. And so that means we need a 0 for a placeholder. And we get 0.0157964 hectoliters. All right. One more before we go to 7.2. So up to this point, we've converted from while in U.S. U.S. measurement, we converted while still in metric. Now, if we want to go from U.S. to metric or metric to U.S., you would need a conversion factor like we did earlier. So 55 miles to kilometers. The 55 miles is U.S. The kilometers is metric. Once again, you can find this conversion factor, anywhere. We got 1.61 kilometers is equal to 1 mile. So set it up like we were doing our conversions originally. So there's only two different ways we're talking about converting. Either you're going to have a conversion factor, and that means you'll have to use this fraction setup, or you're using just the metric system where we're moving our decimal, 2 places to the left, to the right, or whatever the case may be. And that metric conversion is you only can do it metric to metric. So that's just moving, your decimal to the right and left. No, you do not have to memorize the conversion factors. No, you should have those at your disposal. All right. So we set it up. We have 55 miles over 1. Use our conversion factor of 1.61 kilometers over 1 mile. Our miles will cancel. Our measurement of miles will cancel. Remember, that's what we need. And now we're in kilometers, which is what we were looking to do. 55 times 1.61 is 88.55. And that would be your answer, 88.55 kilometers. All right, I think that's a hand. Yes, Mr. DeFore.
Can you go over where you got the 161 over 1 from?
Oh, from the book?
Oh,
You're
okay,
talking
so
about
you, Oh, you just going
So,
over problems on the book. Okay.
no. Well, let me make sure I understand what you're asking because I just jumped on that. Are you talking about this or are you talking about that? You talking about the fraction?
Oh no, never mind. I missed where you canceled out both of my house.
Okay. Okay. So you good to go?
Yes.
Okay. All right. Cool. But yeah, I got this problem. I got the problem for the book as far as an example, and then the conversion factor was in the book as well. Now, this conversion factor you can get from anywhere. Like I said, if you were to ask Siri how many kilometers in a mile, they should give you that. Or if they say how many miles in a kilometer, this relationship would be a little different, but the calculation would end up giving you the same answer. So, yep. So I will do that. Any questions or any other questions about converting your measurements before we look at 7.2? All right, see some nodes there. Oh, all right. So let's go to 7.2. We'll look at a little bit of geometry, and then we should be good to go for today. So basic concepts of Euclidean geometry, and that's just geometry, Euclidean is just, specifying where we're coming from, but, geometry, that's the main thing we worry about. Okay, so our first example, X, Y, and Z are all on line L. Given that XY is equal to 9 meters and YZ is twice XY, find XZ. All right, so this is our little diagram at the bottom in black. We have X, Y, and Z are all on line L. XY is 9, YZ is twice XY. So I'll give you a chance to write that. All right, somebody has a possible answer. Let's see if he's right. Oh, I didn't look at the name. Yeah, see if he's right. So now you say 18. XY, you're right, is twice. YZ is twice XY, but remember we're looking for XZ. So it says YZ is twice XY. So, they give us XY, they give us a relationship to calculate YZ, but we want to know what is XZ. So now you don't necessarily have to set this up in equation form. You probably can figure it out without an equation. I'm just going to do that because this is a math class. And but this is how you're going to be processing it in your mind as well, whether you write it out in equations or not. So we got xy plus yz is equal to xz, right? Xy, yz, add them together, you get xz. So they give us the relationship that yz is 2 times xy, it's twice xy. So I just went ahead and substituted that piece in, that yz is equal to twice xy. Then they told us that xy is equal to 9. So that's where your classmate suggested 18. So that's 9 plus 2 times 9. 2 times 9 is 18, and then 9 plus the 18 is 27. So the whole segment of xz is equal to 27. Xy is 9, and yz, though, is at 18. So they wanted this answer right here. Once again, even if you don't do this whole process, as far as writing it out, that still is the process that you would take on mentally as far as calculating what's going on. So, all right. Any questions before we look at the next one?
Yes, I don't know what you just did. My screen keeps blanking out, so I have to leave and come back in. Can we do another problem?
Yep, next one is just like it.
Oh, okay. Sorry. Thank you.
No, you're fine. You're fine. Because there was no guarantee I was doing another one like that, so you're fine. All right, so next one. Hold on. Did somebody say something in the chat? 27. Yeah. Yeah, he dropped that 27 on me. Okay, cool. So A, B, C are all on line L, just like before we had X, Y, Z. This time, BC is 16 and AB is 1/4 of BC. Find AC. So this time they give us BC to be 16. They give us a relationship right here, 1/4 BC, and then they want to know what is the whole segment AC. Give you a chance to write that before I scroll down. All right, so if we look at how this one is set up, AB plus BC is equal to, AC. So that's the equation. All right. So they give us BC to be 16 and then tell us that AB is equal to 1/4 of BC. So I just substitute that in right here. Once again, you probably be able to figure this out without setting it up in an equation form. That's fine. I'm just going through the equation process just because once again this is math class and to give you a structure on it. But yeah, mentally this is what you would be doing. And I think I saw somebody in there. All right, I think somebody got it. So throw in that 16. 1/4 of 16 is going to be 4. And here in that red, you see how we went about doing that. 1/4 of 16, the same thing as 1/4 times 16 over 1, multiply across, that'll be 16 over 4. 16 divided by 4 is 4. And so, like I said, that's what I got right here in the red. And then 4 plus 16 is 20. Yep, good job, sir, good job. Questions. Make sure we're okay. So they give you a piece of the segment, then they give you a relationship for the other piece, and then you just plug in accordingly. And in this case, in both of these cases, add them together. All right. Okay, scroll up. All right. Parallel lines, just lines that never cross or never touch each other because they have that same incline, same slope, same slant. Perpendicular lines are lines that create a 90-degree angle at intersection. All right, so in that diagram, you see we have that red square. You can never assume that you have 90 degrees. You need to see something of that nature. Either you need to see that red square, or in the directions, it has to say that these lines are perpendicular. But you can never assume that you have perpendicular lines. 89 degrees will look like 91 degrees, to the naked eye. So you can never assume that you have 90 degrees. All right, angles are two rays with the same endpoint, and that endpoint is called your vertex. All right, we have a few types of angles. First type is acute. It's when the angle is between 0 and 90 degrees. We already talked about right angle. That's when it is 90 degrees. And once again, don't forget you need to see that square to know that you have a 90-degree angle. Obtuse is between 90 and 180 degrees. Probably should have wrote between. So obtuse angle is between 90 and 180 degrees. Straight angle is 180 degrees. That's just a straight line. Then a full rotational revolution, 360 degrees. Complementary angles are two angles that add up to give you 90 degrees. Examples of that, 50 and 40. 50 and 40 are 90 degrees when you add them up. 8, 89, and 1 are also complementary angles. When you add them together, you get 90 degrees. Supplementary angles, two angles that add up to give you 180 degrees. So just a couple examples of that, 150 and 30 degrees, 2 and 178. All right, any questions before we look at the example? All right. So Next example, given that, and whenever you have an M sitting in front of this symbol, hold on, let me see if anybody says something. Yeah, that's all it is, geometry. Yep. So given that it said whenever you have this M sitting in front of this symbol right here, it looks like angle, that just means the measure of angle ABC. So given that the measure of angle ABC is 84 degrees, find the measure of angle X. So they give us this diagram right here. And he wants to find X. So notice that ABC is sitting on the outside, and they're saying that that is equal to 84 degrees. They give us 47 degrees and wants to find out what is this missing piece right here. So once again, whether you set it up as an equation or not, is not that big a deal as long as you know how to find the answer. And all we had to do was take 84 and minus 47 from it to figure out what X is. You know, this whole thing is equal to 84 degrees. You know 47 of it, subtract it from that 84 degrees to find what X is. All right, any questions? All right. Next one is vertical angles formed by intersecting lines. And they will be the non-adjacent angles, and they are equal. I'll give you a chance to write that before I scroll up. All right, so we have two lines that intersect. Let me do this. So we have two lines that intersect. The angles that are opposite of each other will be the ones that are vertical angles and equal to each other. So 1 and 3 are the angles that are equal, and then 2 and 4 are the angles that are equal. And they're equal according to this vertical angle relationship. All right. All right, let me erase some of this stuff. All right, so they tell us or ask us to find the measures of A, C, and D, and they gave us B. All right, so you can use the vertical angle relationship in order to find out the angles of the rest, or at least to find out D, because we're looking at, whoa, hit the wrong one, there we go. So when we look at B, B and D are equal to each other because of vertical angles. So that means D is 115 degrees. And that's because it's a vertical angle with B. All right. Yep. So looking at the next two to find, it doesn't matter which one you find first, whether it's A or B, but you A or C, excuse me, but you recognize that a straight line is created between the two, a straight angle. So you would take 180 and minus 115. Let me see, did somebody say something to me? Yep, you got it. So 180 minus 115 will give you 65 degrees. And so you found that because it was a straight angle with B. And the straight line is equal to 180 degrees. So once again, we minus 115 from 180 to figure out what A was. And then if you want to find C without any calculation, you recognize that C is going to be equal to A. So C would be 65 degrees as well. And that one is a vertical angle, excuse me, vertical angle with A. All right, any questions? Be sure. All right, sounds good. Let's look at the next one. Erase a few things. So we have L1 and L2 are parallel lines, and then T is a transversal. That's just a line that goes through or cuts through our lines. So let's see if I'll give you a chance to write that, and then we'll go into the relationships. All right, so we see that AB, D, and C, we're labeling those angles up here, and then X, W, Z, and Y, labeling those down here. So the first relationship is alternate interior angles. So it's in the wording. Alternate means alternate sides of your transversal. And then interior, you're talking about the inside of your parallel lines. So alternate means alternate sides or opposite sides of your transversal. Then interior, once again, is inside or the interior angles of your parallel lines. They're going to be equal. So that means you're talking about D and X, W and C. So they're on alternate sides of your transversal, and they're on the inside of your parallel lines, the interior. All right. Next one is alternate exterior angles. That's important because they are equal. So you're talking about exterior. If these are the interior, that means these are the exterior. Once again, you said alternate because so now you're talking about the opposite sides of your transversal. So A and Y, B and Z. They are the ones that's going to be equal. All right. Any problems? Okay, so the last one, corresponding angles. All right, let me make sure no one's saying anything to me. All right, cool. So the next one, corresponding angles, and we'll go back down in a second. Just want to give you the visual. All it's saying is that these angles right here, these four angles correspond to these four angles right there. So A and W are equal, B and X are equal, D and Z, C and Y. And that's what we have right here. Corresponding angles. AW are equal, BX are equal, CY, and DZ will be equal. All right, any questions before we use it? All right, sounds good. So in the diagram, it says L1 is parallel to L2. So this symbolism right here just means parallel. And they give us angle F is equal to 58 degrees. Find the missing angles. So let me erase this stuff so we can walk through it. Give me a second and I'll scroll back up. All right. So there you go. Diagram. L1 and L2 are parallel. In this diagram, angle F is 58 degrees. I'm going to find the rest. All right, so let's go. Once again, we have F to be 58 degrees, the one we can start off with no calculation. The easiest one to start off with no calculation would be H. Notice that is opposite of F. I'll go with purple. So H is going to be 58 degrees, and it is a vertical angle with F. Okay. Next one, and we have a straight line right here with G, or you could have done it with E. It's up to you, doesn't matter. That's 180 minus 58. So it'd be 122. And that is a straight angle with F. Yep. What is geometry? Someone asked, what are these types of problems called? For the most part, it's just geometry. Finding the missing angles. But they don't have a specific name. If you're talking about, if I look up Well, I would say if I were to look this up, I would say finding the missing angles in geometry. So some problems should pop up for that if that's what you're looking for. Well, yeah, finding the missing angles. All right. And then E, and with all of these, there are multiple ways of finding these answers. As long as you use the proper relationship, you still should get the same result. When I look at E, use it or find it by establishing this a straight angle with F, or I can just already know that it's 122 because it's a vertical angle with G. So either way, you should get 122. All right. So now, a couple ways we can find out A, B, C, and D. One way is to recognize that this cluster corresponds to this cluster. So if I want to start off with A, I know A is 58 degrees because it's a corresponding angle with F. F. In other words, it's the same thing or equals to F. Same thing with B. Now I could use the fact that it's a straight angle with A. I could use alternate exterior angles, but I'm just going to use the fact that it corresponding angle with G. Then C, 58 degrees. Once again, there are multiple ways to figure out what C is. I'll use vertical angle with A because it's opposite of A. And then D is 122. That's a vertical angle with B. All right. So also recognize, try not to make this, more harder than what it could be. Recognize there are only two answers, 58 and 122. So it's just alternating between 58 and 122, just making sure you put that 58 and the 122 in the right spot, of course, in the right spot. But there was only two answers really, 58 and 122. Just have to use your relationships properly. All right, then we got one more example, then we'll be done. Questions on this one? All right. So I believe this is last. Yep, it's the last one. So angles of a triangle, they add up to give you 180 degrees. So they don't have to mention anything about this relationship as long as you know that you see a triangle or they say that you have a triangle. Do you know that the angles inside of your triangle are supposed to add up to give you 180 degrees? All right. All right, so last example for the day. It says in the diagram, angle C is equal to 40 degrees, angle E is equal to 60 degrees. Find the measure of angle D. So let me erase some of this stuff. I'll double back. Let me erase this stuff though so we can walk through it properly. All right, so this is the diagram. Angle C is given at 40 degrees. Angle E is given at 60. They want us to find the angle, the measure of angle D. All right, somebody said 80. Let's see. So we see that we have a triangle on the inside of here. We want to find the outside angle of D. In order for us to be able to do that, we need to know what B is, though. Oh, didn't mean to do that. So let's look at our given. Now, we can figure out angle A because it is a vertical angle with angles E. Yep. All right, and now we can find angle B because you know that this is 60. So we can do 180 minus 60 minus 40, and that'll give us 80 degrees. And that is because angles of a triangle. Remember, all of your angles in the triangle has to add it to give you 180. We knew two of them. We knew that one of them was 60 degrees, the other one was 40 degrees. So if I subtract both of those from the 180, that will give me my third angle, which is angle B, and that's 80 degrees. And then to find what we're really looking for, which is angle D, we see we have this straight line right here between B and D. So I will do 180 minus angle B, which is 80 degrees, and that will be 100 degrees. That's my answer. And the reason being is because that's a straight angle with angle B. All right. So they wanted us to find D, but we had to find all of the other angles in order to get to angle D. All right. Questions, questions, questions. Yep, I saw it. I didn't want to give it away yet. So, yep. Questions on anything. So you see, it really is all about taking the relationships that we've been given, whether it be in 7.1 or 7.2, talking about conversion factors and your measurements, or you're talking about these angles and trying to figure out, which ones are equal to the next. It's all about getting used to using these relationships and using them properly. Some questions may not come up until you actually start doing the work. And so, this is your opportunity now. We just done 7.1 and 7.2 as far as lecture is concerned. And so jump on in there, start working on stuff. If you have questions, feel free to email me. Or I don't know, next class I might open up the floor, but if not, at some point I will open up the floor for questions. And we'll take time out and answer whatever questions you may have. But like I said, if you can't wait for that moment, feel free to email me, and we'll do that. And if you need a time outside of class, shoot me an email so we can set that up. So outside of that, questions, concerns, or comments before I let you guys go for today?
No, I'm good.
All right, appreciate that. Appreciate that. Okay,
I'm
if I'm
straight.
all right, cool, sir. Appreciate it. So if everybody's good, I will see you guys on next class. That'll be Thursday, and get ready to get this weekend started. Get ready for the Super Bowl, right? So
Yeah.
outside of that, maybe we'll do
Yes,
some extra credit on the
sir.
Super Bowl. Maybe we'll do
Let's
some
see if
extra
Tom
credit on the
Brady
Super
gonna
Bowl
get
or something
back
like
in there.
Yeah. Maybe if you go over Tom Brady, I'll give you 15 points on the test or something. We'll talk about it then. All right. So outside of that, I'll talk to you guys next class. Don't let me forget though. I'm serious about the extra credit. And
Okay.
see you guys on next class.
All right. Have a good day.
All right, you the same.